So this next example is our first instance where we have a missing term for synthetic division. So we look for perfect descending order. We go highest degree is 4, then 3, then 2, and then 1, and then we're missing 1, the last one. And if we don't fill it, we will have problems with synthetic division. We are dividing by a linear, so we can do it. So we're going to write x plus 4, set that equal to 0, and solve. So we subtract 4 from both sides, and that's going to give us x equals -4. That goes in my little half box deal. And then I'm going to bring this polynomial down, x to the 4 plus x to the third minus 14x squared minus 10x. And then we're going to go ahead and bring our coefficients out of there. So remove it of the variable. So we got the 1 comes down, 1, -14, and -10. Now, there is a missing term. We have a constant that's missing. So I needed a 0 there. There technically was a 0 there that wasn't, visible. It's just 0, so we didn't have to write it. But we need it to be present to win our synthetic division process. So we go ahead and put that 0 in there and then complete the process. You bring down a 1, and then we do the same algorithm. We multiply by the -4, bring the answer underneath the next constant coefficient here, which is going to be a -4. And so 1 times -4 gave me the -4, and then I add and get -3. And then continue the algorithmic process. And we multiply here by -4. -3 times -4 should give me a +12. I add and get a -2 and continue. -2 times my -4. Put the result over here to be a +8. Add, get a -2. If I continue, I should get the same answer as the last one, so I'm going to put an 8 over here. And then the deal is, if I didn't have the 0 here, I would have stopped at the last one and called that my remainder. But it was not the remainder. The 8 coming down is my remainder. And so it's important to have this extra term. It's huge, so that I can have the 8 lined up in the right place to be actually called my remainder. Otherwise, I would have messed up and called the -2 my remainder. Now, to finish, every time we took a highest power and divide it by a linear. So we go 1 power down in my result. So this is going to be x to the third minus 3x squared minus 2x to the 1 minus 2x to the 0, and then plus my remainder term. My remainder term, I want to just write it as a fraction. That still needs to be divided by my x plus 4 because it didn't go in evenly. So to write it all nice and pretty, one line, x to the third minus 3x squared minus 2x minus 2 plus fraction bar, remainder 8 over x plus 4 because the x plus 4 didn't go in evenly. So that's what we do when we have a missing term, and we'll have another one here on our next problem in the middle.